Okay, so I just wanted to show you guys something that I'm interested in, have been interested in recently, is building my own wind turbine and building a VAWT more precisely. A VAWT is a vertical axis wind turbine, as opposed to a HAWT, which is HAWT, which is a horizontal axis wind turbine. And what I'm interested in building is a axial flux permanent magnet generator. And so these are a number of the videos that I've collected in a playlist on the subject, as you can see. Although I've got an Irish learning video in there as well. Sometimes on the Android phone it saves a little bit weird, but as you can see, there's different methods and different ways of going about it for the different voltages. I think what I'm going to be doing is a 24 volt permanent magnet axial flux generator. And I don't know if I'll be going dual or if I'll be going a single, let's see, rotor. So the stator is what the coils are on. So if we just kind of like look at one of these here, I'll just pick one out and see what is times my coils or the belly jack. And we'll look at this one. I was interested in because it was so small. It was so small, and
for just $67.
Oh, go away. Go away. I'm not interested in your adverts.
Pick up a camera or use any fancy editing software. With Doodly, you drag.
Back off with your doodly. All right, so.
Hello, this is Mad Scientist Hut Channel.
So this guy's using, like, it's quite small, and what you do is you set the copper coils in resin, and it's three-phase. So the difference between three-phase and direct current is AC and DC. Three-phase is what you get out of the walls of AC. AC electricity travels better through the cables over longer distance, whereas direct current loses through impedance, loses energy and potency over distance through the cables. And so to build one of these, you build it so in three phase. So basically, if you see there's nine, I think he's got 9 coils around embedded in his resin there, and basically it's 3, 3, and 3. And you kind of take the top one. Say if you take the top coil there, you match that to, you link it up to, we say counting down 1, 2, 3, the third one around, and then you do again 1, 2, 3, and you match those 3, and you do the same with the next one that goes to the next 3, and so on and so on, and so until you've got 3 and 3 and 3 coils matched together. Okay, and basically that's how you get AC electricity from this thing. But how you actually get the electricity from this thing is the spinning magnets that spin over the copper coils. And I think I'm going to go with round magnets to go over those copper coils. I don't know how accurate this is, but this guy seems to have gotten a hell of an awful lot of electricity from his. We'll just have a quick look at it.
Today we're going to go over a 3-phase generator that I made, and I made it from scratch. So first thing, please subscribe to my channel. It's really important to me. And alright, so let's go.
And he's used
over the generator.
He's used skateboard ball bearings in the center there, and obviously that's where the shaft goes straight down through the copper coils go in the middle, and then on top of that, that is the stator, the rotors, which have the magnets on it, spin, and they're attached to the shaft that that goes up and then has the blades attached to it. So you've got different types of blades. You've got the type of one that I would like to build has airplane shaped, you know, the lift and drag shape, so that there's more of a surface curved over less of a surface curved, and basically that increases airflow over one side. And so it's for spinning in lower winds. It's for spinning with lower RPM, and so rounds per minute, I think is what it means. And you've got to set up the right amount of coils. So you've got to wind those copper coils a certain amount of times, anywhere between 30, 40, 50, 60, 70, 80, 90 times, and you build a special little device that rotates it. And some guys have counters, click counters down here, so that every time they go over the click counter, it clicks at 1, clicks at 2, so they don't miscount. The click counter lets them know. But you've got to, as you're guiding the copper coil off the copper wire off of the coil and around your rotator, you've got to guide it with your finger so that you're getting it very, very evenly spread. And you've then used zip ties, or you use tape to actually hold the coils in place. If I show you here, that's a coil winder there. See that there? That is a coil winder, and so that gap there is basically where the zip tie or the tape goes in under the. No, I think actually maybe that's the gap for where the wire comes out at the end and the beginning, for the connection to the other two coils. But you do have to leave a gap in the little tool to actually put the there's resistors. Those things are resistors. Basically, that's for a dump load. So basically, if you've got a very good windy day and your batteries are full, you don't want the turbine to keep spinning and actually sending electricity to your batteries. You want to divert it. So it's also called a diversion load. So you get those things. Those things there are resistors. They're heating elements inside of ceramic. And basically, they burn off the what excess energy is leaves the electrical circuit through noise and through heat. That's how excess electrical energy is lost. It's lost through noise and through heat. Somebody correct me, there may be another way, but they're the two ways I know of. So what a lot of guys do is they divert that using a solenoid. So if it's a 12 or 24 volt solenoid, you basically set it so that the wires come in from the turbine, but then when it gets up to, we'll say, they go from the battery, I think. So when the battery comes up and lets the solenoid, fills it with 12 volts, exactly 12 volts, it switches. And that switch, that's what the solenoid is built for. And so basically it switches to send the electricity out to the diversion load, the dump load. And so this is something that I'm quite interested in at the moment, and they're the battery packs. You get the LiFePO4, which is lithium iron phosphate, which is a safer technology than lithium ion. Lithium ion are very good. They're very intense. The density of energy for the size is a lot greater, but that also means that they're a lot more dangerous and that they can run into thermal runaway if you don't control if you don't have a battery management system, a BMS, which actually, like the dump load, the diversion load, the solenoid, cuts off the amount of electricity going into the battery as you charge it. That has to be cut off by the BMS, because if you don't, there'll be thermal runaway, which is an exploding battery going up in flames. Whereas the lithium ion, the batteries which are used for electric bikes and things, are those kind of batteries. They're very high density of electricity. Lithium iron phosphate is a safer energy, but they're bigger batteries. They're bigger batteries with lower voltage. If I get that right, 3.2. Each one of those batteries you see down there, each one of those is 3.2 volts, but they're large amp hour, which is the capacity. Amp hour is capacity. So, so I mean, if anybody's interested, we can talk more about this. We can go through these. I'm not sure if I should start opening up some of these videos, but that guy there, DIY Solar Power with Will Prowse, he's very good for the battery side of things. He reviews an awful lot of different types of batteries and inverters, and you can go check out his channel. But let's see who we have down here. Ben 0 Point, John Daniel is good too. Um, Open source low tech is also quite good. He shows you how you can build these things for quite cheaply to actually get into the technology at a budget level. This guy called he's very competent. Let's see, where is he? Probably up here somewhere. James Bigger, yeah. James Bigger. He builds electric vehicles. Even he built an electric bike. He's building an electric cart. But he also built his own wind turbine using this technology, and he did it very, very well. He used vacuum molding to create the resin mold holding the copper coils without any air bubbles. So he really went for it. He created a very finely made end product. Whereas this one here, obviously, obviously this guy just threw some resin in around the copper coils, but he seems to have gotten a really good result. And that's if that's true, if that's real, I'm very impressed by it.
Generator. I made these coils by hand and shaped them, and there's 9 coils here. Every third coil, so this one is tied in series with this one and this one, and then so on and so forth. So this one's tied in series with this one here, and then this one here. And then they come out to this little
this is where you rectify
bridge
it.
rectifier.
Basically, that's when you change it from AC to DC. And obviously, you would leave the wires from the AC longer to get to your battery source, which is DC, direct current, two wires, power and ground,
Made to rectify the 3-phase
Now, he's just made...
voltage.
I'm trying to get it clearly.
Into...
Yeah, he basically just took diodes. A diode just takes the electricity and it goes in one direction. So it doesn't allow it to send it back. So that it turns your windmill into a motor. See, so basically these are what are basically inside an electric bike motor as well in the hub. Basically, it's the same thing, but they're optimized differently, But they're basically exactly the same technology. So what a diode does is it sends the electricity from the spinning rotors over the stator there, the magnet spinning over the copper coils, and it sends the electricity out to the battery. But if you didn't have diodes stopping the electricity from coming back, at any point, when the wind dies down, the energy could come back up from the battery, send out to this rotor, the stator, the turbine, and actually turn it into a motor. So it would actually just start spinning your blades like an airplane. So, which is not what you want. Like, you want it to generate electricity, not use electricity. So the diodes basically send the electricity out one direction. You can buy a bridge rectifier pre-made. I mean, you buy them from AliExpress, you buy them in your local, I don't know, maybe hardware stores, electrical places have them. You can buy them fairly cheaply, and it just depends on the amount of amperage that they can handle. 24 volts won't be that much. I'm gonna guess that the amperage of the bridge rectifier that I'll be using will be 20 or 30 amps. I could be wrong about that. I'm still getting to know this, how to do this. So I'm just going to check on OBS here how long I've been going for. 13 minutes. All right, so hopefully that's still going okay. So yeah, we'll just listen a bit more to this guy, and then I'll wrap it up. And if you want me to talk about it again at a later stage, we can.
2 wires, so it's a rectified DC waveform. That way we can measure it on the multimeter in DC. I poured epoxy around the coils and put a bearing in the center of it, a 608 ZZ bearing. So we have a free spinning around the coil. And then for the...
Now, what I will say is that if you're going to step it up a bit and make it a good structure, I was talking to some guys on a forum, and basically they were telling me that you can use tapered bearings. Tapered bearings are often used in motorbike headsets, and they're used on a lathe, you have tapered bearings, which instead of they just being ball bearings inside a race, basically you have the race which holds each individual slightly longer cylindrical bearing all the way around, but it's tapered at an angle so that the load it takes the load better when I forget what they call it, when it shifts. So with the weight of a wind, the blades of the propeller spinning a shaft, basically tapered bearings will deal with that load better and that movement better, But this is just the basics. Like
magnets, I have these. I think they're N40.
You can continually optimize, is what I'm trying to say.
They're only a millimeter thick, and I think they're 10 millimeters wide. I'm pretty sure they are.
And these are neodymium magnets. Neodymium. So basically, China has a glut of these. You can get these very cheap from places like AliExpress. You get them circular like that. You can get them rectangular. You can see on a lot of the videos at the side there that the magnets are actually rectangular. They're not circular. That's why you get those coils. The coils are designed to actually, the coils are designed to work with the shape of the magnet as best as possible. So there's a round one. You can see that's specifically round, but you see down here that's quite rectangular. So that's the reason for that. All right.
Maybe they're 12. I'd have to look them up. And then I have two plates, and they're both attached to the backside of a steel plate that I cut out of a power supply chassis. That's what this material was. So let's put it together.
Okay, so I'm going to leave it at that. You can go check that video out for yourself. You can see the title of it there. Homemade DIY Free Energy Generator Small Home Power. And the channel is Mad Scientist Hut. So you can check that out for yourself. I got stuff to do, so I got to go now. So I just wanted to play around with the new working with the integrated webcam, and I also wanted to share with you what it is that I'm interested in my project, my big project at the moment. I'm locked onto it. I want to get it done. I'm interested in getting this done. So if you want to follow along with me, that'd be great. And I'll leave it there. Take care. Have a great day. Okay.